often in acid-base chemistry you get asked to calculate the pH of a solution. However, there are also a number of examples where you get asked to calculate the concentration of the acid given the pH of the solution. So I want to look at one such example. The pH of a solution of nitric acid is 3.4. Determine the concentration of nitric acid in the solution. Okay. Well, now you need to remember that when we talk about a solution, we're always talking aqueous solution for our purposes. And so if we put nitric acid, which is HNO3, inside water, it will ionize to form the nitrate ion and the hydronium ion. And that goes back to the definition of an acid, Arrhenius's definition, which says an acid will ionize in water to form hydronium ions. Okay, so if we look at this equation, we can see if we can get the concentration of hydronium, we can then use our ratio, which in this case is a 1:1, to get the concentration of our nitric acid over here. We don't need to know the volume in this case because it remains constant. So all we need is the concentration of hydronium, and then we got the concentration of nitric acid, which is what the question is asking for. The only information we're given is that the pH of the solution is equal to 3.4. We're not given anything else. Okay, so where do we go from here? Well, we recall that the pH definition is minus log times the concentration of H3O plus. And that is equal to 3.4. Okay, and what I'm going to do then is just isolate the log by itself. So I get log of the concentration of hydronium is equal to minus 3.4. And now I have got a mathematical equation that I need to solve. And some of you might not be so familiar with this, so I just want to remind you from math. If you've got a log of some number, let's say y, which is equal to some other number, let's say x, and I want to write this equation in terms of y. In other words, I want to work out what y is. Well, then I need to remember that log is always to the base of something. If it's not written, it's always to the base 10. Okay, so then if I want to, so to speak, get rid of the log or find what y is, I take whatever the base is and I write it on the other side of the equation. And whatever is already on the other side of the equation, that then goes inside the exponent. So the base was 10, and on this side of the equation was x, so it now goes into the exponent, and I get 10 to the power of x. And then whatever was inside the log, so this was log of y, for example, that is what remains on, the original side of the equation. So log to the base 10 of y is equal to x, which means y is equal to 10 to the power of x. Okay. So that's exactly what we're going to do here. We know that this is log to the base 10. So on this side of the equation I write 10. Whatever was over here now goes to the exponent. So the minus 3.4 is now in the exponent. So I get 10 to the power of minus 3.4. And what I'm left with here is what was inside the log, which is the concentration of H3O plus. Okay, and as a result, I can now work out the concentration of H3O plus. I just get my calculator and I type in 10 to the power of minus 3.4, and there's my answer over there. Now I can either write this in the decimal form, or if you prefer, you can go shift, setup, and push number 7 for scientific, and then number 3 for 3 digits. And I get 3.98 times 10 to the minus 4. And that's my answer. 3,98 times 10 to the minus 4 moles per decimeter cubed. It's a concentration. Okay, that's my concentration of hydronium, which I also know in this case is equal to my concentration of nitric acid, simply because it's a 1-to-1 reaction over here and the volume's not changing. Alright, and so I've answered my question. Just two things before I end this video, and that is coming back to the calculator. If you don't like scientific notation, or you get to another part of your exam and you prefer just to have decimals, you just to change back, you'd go Shift, Setup, and then for 8 for normal, and then always push number 2. And there it goes back to decimals. Very handy trick to use. Some sections lend themselves well to scientific notation, other sections better to just the normal decimal format. Okay. That was the first thing. The second thing is, in this example, I asked you to calculate the concentration of the acid. You could also be asked to calculate the concentration of a base. So, for example, you could be told that the pH of a solution of sodium hydroxide is 10.2. Okay, and it's a solution of sodium hydroxide. Calculate the concentration of sodium hydroxide. And you'd follow this exact same procedure, except when you get to this step, you've now got the concentration of hydronium. Yet you know sodium hydroxide would react or dissolve in water to produce the hydroxide ion. Okay, so to get this concentration of sodium hydroxide, you need the concentration of the hydroxide ion. Yet this method over here gives you the concentration of hydronium. So the only extra step you need to add in is you need to remember this equation, that the concentration of hydronium times the concentration of hydroxide is equal to 10 to the minus 14. That comes from the autoionization of water. And what you've got the concentration of hydronium from following this procedure over here, so you just substitute it in, then you can solve for the concentration of hydroxide and so get the concentration of your base. So it's one extra step. It would also be one extra mark. There we go.